Cool. Well, thanks so much for giving me the opportunity to be a discussant, and thanks to the presenters today. I understand we have about I'll talk for about 10-ish minutes, and I understand we've got about 40 minutes for discussion, including that. By way of background, I'm an epidemiologist and faculty member at Johns Hopkins Bloomberg School of Public Health. My interests are in cognitive aging, and I work on the Gateway to Global Aging with Jin Cook Lee. I'm also co-I on HCAPS in Kenya and India. So at the outset, this was a tour de force of a lot of really exciting talks. And one thing that I want to highlight before we get into the details of each of these talks, I have some prepared slides on them, is that we just saw a whole session of talks about cognition and education in lower middle income countries without using a high income country as a reference group. How cool is that to be able to do? Welcome to the 2020s, and thank you to the NIA for funding all of these exciting studies that are enabling this type of research. But anyhow, so I have some brief, fairly relatively unorganized slides about each of the talks, and let's go through them. So Vikesh's talk was on causal effects of schooling on memory in older ages, and he did a cross-national study of 5 low-middle income countries in Mexico, China, India, Ghana, and South Africa. The goal here was to evaluate a causal relationship between schooling and cognition in lower and middle income countries. Most of the research, as was pointed out in the paper, comes from high income countries. And so this type of research is sorely needed and useful and important. One sort of issue to think about is the definition of less or lower education can be culturally dependent. So there was a recent paper by, I think, Mukadam and colleagues, which looked at these tried to reproduce the Lancet Lancet PARs in India. So we saw this snake figure that suggests that 7% of dementia prevalence could be reduced by intervening on lower education. And the one issue is that in papers like the Mukadam paper, they used a definition of less education that comes from high income settings, which is namely if you have less than 8 years of education or less than secondary education. If you apply that rule in the LASI Dodd sample, that represents about 79% of the sample. But perhaps more appropriate definitions for what low education is might mean no formal education, which embraces about 55% of samples in India. The prevalence, as well as an association with the outcome, is what computes a PAF. So the reason this is important is because the PAFs can be different. And so we want to think about what's a culturally relevant measure of low education. Is it no education? Is it less education? If it's the latter, what's your cutoff? Vikesh's study does not assume that years of education is linearly related to cognition, so that's a strength. That's a good thing. I was impressed by a thorough literature review. I would humbly suggest there was a paper that came out in Journal of Gerontology by Yuan Zhang just earlier this year, like in the last month. I think it could be relevant to your literature review because she looked at educational attainment and cognitive outcomes across 5 HCAP countries. And I believe she's here and in this Zoom, so we can talk more about that later. This paper used a non-parametric partial identification approach, and the authors have used this in the HRS previously to look at causal effects of education and cognition. Um, the approach makes some weak and I think reasonable assumptions about education and its association with memory, such as that there's a monotonic positive relationship, and they used an instrumental variable of height, which I thought was innovative. One assumption that I saw, and I think this was in your paper, I'm not sure it was in your slides, is that people with more innate ability tend to have more schooling. And that tends to be true on population levels, although that's not necessarily always viable in cross-national research. And it's something to pay attention to. Namely, it can be a problematic assumption in countries that have or had, 40 or 50 years ago, more meritocratic educational systems or a history of such systems. So that's something to think about as you do this. As I was listening to your talk, and again, I apologize. I don't think you presented this, but these are histograms of the distribution of your outcome variable in each country. And I'm always kind of like staring at data, sometimes to my own detriment. And I thought it was interesting that there are data peaks in particular in the same place in Mexico, Ghana, and South Africa. You use data from the SAGE studies, and I just thought this was interesting. It looks like there may be some sort of an artificial ceiling. You might want to check the data. Um, um, it could be something. Maybe it's just happened, just a chance finding here. But anyway, some takeaways from this study. Education is associated with memory, and there's an especially large jump in later life memory, going from no education to a primary education across many of these countries. That's really cool. How to quantify education. So in this study, this study focused on educational attainment. Um, and this gets around the sort of our rhetorical conundrum of, is a year of education in India comparable to a year of education in Mexico or China or the US? Probably not. But does a primary school education carry the same meaning across different countries and contexts? Could there be differences in calendar time across which the meaning of say a primary school or secondary school education has relevance? In other words, are there period effects? It looked like, Vikesh, in the chat, you did mention that you're running models right now to try to piece apart cohort differences in your associations. So I look forward to seeing what those say. And you did also discuss quality of education, which is another excellent and good idea, a good way to quantify education. I think an interesting future direction for a lot of these studies that are coming from low and middle income countries, such as the ones here, but also other studies, will be to identify characteristics and features that distinguish this no formal schooling group. If when you look at the tables, the no formal schooling group represents as little between 40% and 55% of the samples in the studies you included here. So it's a big group. And it's not like these people are walking around with absolutely nothing in their heads. Many have learned to read. They've all learned to function in society in some way. So, just because they haven't sat down at a desk in a room with a teacher in front of it and learned something for 1 or more years, doesn't mean that they haven't learned something. So, understanding in our surveys how we can collect that information and be able to distinguish this group I think, is an important future direction that I'd love to see what it can do. Going on to our next presentation by Yan Zhang, the impact of parity on cognitive functioning using an instrumental variable approach. This paper asked, is number of children associated with cognition in later life? And, she presented some pretty convincing biological and social mechanisms proposed. When I first saw this presentation, my initial thought, I have to be honest, is I am invested in there being a significant positive relationship here, seeing as I have 3 children, the youngest of whom is 24 days old right now. So I would love for this to be for higher parity to be protective of cognitive functioning, but let's see. I might be disappointed. The first thing I wanted to note, and I asked this in the chat, you mentioned that in the Charles sample here, the mean number of education, or the mean number of children in these families is 2.7 children, but I'm sure this is right skewed. You can see that with the confidence intervals for 12 and 13 children. And so, the reason I suggest this is probably less than not J-shaped is because for 99% of the population, you're dealing with people who have 1, 2, or 3, maybe even 4 children. There is, when you limit your x-axis to that point, there is a fairly linear negative relationship. So, and it's only at points where we get to maybe 6 or more children that you start to see a positive relationship. This might be due to rural-urban differences. I would imagine in rural settings, for example, on farms, that more children can help out with the relevant work to be done. I don't know. But yeah, the cognitive outcome was a sum of orientation and immediate and delayed memory and some pentagon drawings. These variables were available in all 4 waves of the Charles study in from 2011 to 2018. One issue that you may want to note is that with this outcome, the 2018 data changed the way that they administer, in particular, the word recall tasks. And they did this in order to align more closely with the HCAPs, which were coming online at that time. But the surveys in 2011 and 2013 and 2015 predated the HCAPs. And what you see here is in blue is the mean recall for the immediate recall, and they're pretty stable in the first 3 waves, and then the HCAP wave in 2018, immediate recall tanks. And then in the first 3 waves of in orange is delayed recall, it's pretty stable in the first 3 waves, and then it shoots up pretty dramatically. The reason for this is twofold, and there are administration reasons for this. Namely, the word list changed in 2018, and it was a fairly more difficult word list for Mandarin-speaking population. But also, there were 3 immediate recall trials. And because there were 3 immediate recall trials in 2018 versus 1 immediate recall trial in 2011 to 2015, there was more exposure to the words, and that's why the delayed word recall shot up. This is a methodologically addressable issue. In fact, some colleagues at UCLA and Columbia right now are working on a method called equipercentile equating to correct the data, and I'm sure they'd be happy to share that with you if you wanted to update things. Another challenge with using Charles data is that you potentially in your models relating parity with cognition, you potentially have some missing data problems, and the data are missing not at random in your models. In particular, there's missing data in these are data from the 2018 Charles HCAP survey, but missing this in the immediate word recall, as well as just about everything, is has a much higher likelihood among people who are illiterate and people who are not Mandarin speakers. So you might want to do some subgroup analyses within these different groups defined by literacy or language of administration. But hopefully your main inferences will stand. At the end of the day, higher parity is associated with lower cognition. That is for me. I'm scared now. And men appear to be at greater risk, although different instrumental variables yield somewhat different inferences, and I can see your area of confusion there. It was unclear to me how you could show coefficients for both males and females, or maybe those weren't coefficients, maybe those were means in each group. I wasn't sure, so maybe you could talk about that. But regardless, these are intriguing implications. And again, it would be really interesting to see how these findings hold up in subgroup analyses. And rounding out our day, we had the paper on cognitive decline and Lifecourse patterns using data from LASI. So this is a cross-sectional study that looked at cognitive levels as they were associated with various early life features. India is interesting. It provides a unique setting given the broad range of earlier and midlife experiences that are really unknown to populations in modern high-income countries, such as child marriage, adolescent childbearing, and child labor, as Kanika nicely laid out. Child marriage has serious consequences for stunting educational and vocational opportunities in women. There's a paper here that I would direct you to, where we looked at differential associations between gender and later life memory functioning, and we did a cross-national comparison between this association in the US and in India. And at the end of the day, I think the conclusion was there is a large gender disparity between the US and India, but that attenuates with larger amounts of education. So more education is good. It probably protects against some of these other things. This study used latent class analysis. So finally, a method that I somewhat understand. Latent class analysis takes an empirical approach to grouping subsets of your sample. Here we saw a latent class analysis of marital age, age at first child, and work experience. There were two issues that I want to highlight here. One is you have a problem in your model of which is a violation of conditional independence among the indicators. In other words, if you enter in an indicator of never worked into this type of model, then you cannot also have all the other categories of started working from 0 to 14 years or 15 to 18 years or more than 18 years. Instead of entering in 9 binary indicators to the latent class analysis to get around this violation, I would suggest using 3 ordinal indicators where you've got marital age, which with 3 categories, and age at first child with 3 or more categories, however many categories you'd like, and then work experience of or the age that one started work, and that can be 3 categories. Second challenge is that when you used your class membership to predict cognition, you used observed class membership to characterize means of covariates and to do regressions. The issue with this is in latent class analysis, when we're empirically grouping subsets of the population, no individual has a perfectly 100% chance of being in any one class. So there's measurement error in class membership. Sort of the degree of measurement error could be described by reporting the entropy for the final model for females and males. I didn't see the entropy, but entropies are usually, even if entropies are like 0.9, then you're still going to have misclassification error. An easy solution would be something called Vermont's 3-step approach, or MPlus's auxiliary command. But use the Vermont 3-step approach. This approach has been around, I think it was first published in 2010. There have probably been advances in new approaches, although as of at least 2 years ago, the last time I dug into this, Vermont's 2010 approach was still viewed as the gold standard for doing latent class regression. Anyhow, moving forward with the results, I saw that the latent class results for women really seem to be driven by marital age. Yeah, and class 3 in particular was distinguished most by from the other classes by having by on average being associated with a marital age after 18 years. This class also has the highest level of cognition, very high levels of education by sizable amounts. I was impressed by these findings. With respect to men, the latent class membership seems to be driven primarily by the age at which one started working, for the most part. An interesting data question that I just want to put out there with, and this seems to be an issue with the LASI data. From your slides, if just 83% of women report their first child after they were 18, why do 98% of men report this? Are men in the sample not acknowledging the children they had when they were children? Or it might be that men marry women, that there's a significant age gap. So that's probably the answer. Anywho, thought that was interesting. In terms of results, the primary outcome I should mention is this really cool and exciting cognitive factor score in LASI that's scaled to LASI Todd, which I think I'm familiar with. We don't have evidence that this score is biased by literacy. However, there are probably easily differences by literacy. So think about adjustment for literacy and other variables related to that. I know that you adjusted for education and caste and a couple other things, but pay attention to that. In general, results suggest that the classes defined by more child marriage, adolescent childbearing, or child labor, more child, and younger child labor, on average, have lower levels of cognition. Across these 3 features, I was particularly surprised at the effect at the association of child marriage with low cognitive outcomes among women. I thought that was particularly astonishing. And I would really encourage you to fix these fairly manageable analytic issues and publish this. This is some really exciting, this is a really exciting finding. Thank you.